Welcome, Mooly.
How do I do it?
Yep. Forward and back. Yep.
Hello, everybody. It's a small crowd, so thank you for coming. I'm actually replacing Chandra, who could not be here because of a visa issue, and unfortunately, I also replaced her last year. So last year, we described the formal verification tool, which is called Satora Approver, which was adopted by Chandra and her team for Soroban. How many of you know about formal verification? Don't be shy. Sounds like all of you, many of you. That's great. So we have adopted this tool. There are a lot of tools, but I think we adopted this tool. There are people using it. There were 2 community efforts, one by Code Arena, one by Spearbit. We really encourage developers to use it. This is not the subject of this talk. The talk was prepared by Chandra. It's a talk to make the ecosystem more secure. And it's related to the talk we have seen previously. Since it's such a small audience, I prefer to have questions in line. So we have so if you have questions, please stop me. It's not a problem. I don't have an agenda. And it's, unfortunately, I'm presenting slides made by Chandra. Also, there is a blog, so please ask me questions. I'll try to do my best. Okay. So I think after the session, we have seen security is a big issue for smart contract, not only for smart contract, for the whole ecosystem. We have seen this morning with Thomas talk about confidential transfer. Security is a big issue in the crypto system, and you have to be very careful about it. So because security is a big issue, there are a lot of tools, and many recent tools. I, of course, point out our tool, the Satora Approver, but other tools by runtime verification, academic tools, other tools, even Amazon. A lot of people are contributing interesting technology that can be used in this content. And I encourage you to use all of these tools. I think all of them are open source. Many of them developed specifically for this domain. So this talk, I'm going to try to explain 3 things, and I think each one is interesting, and they are all together. So first of all, how can you, as a developer, help formal verification or auditing? How can you make our life easier? And we can tell you, Satora has been around for almost 8 years. We have been working with the top protocols, and I think we're helping them. But every time we feel like they're coming to us too late, and they're coming to us with too complex code. And ideally, we want to convince them to write the code which is better for us and better for the community. And I think what Chandra did here is something based on the small experience we had in the Soroban, and we want to encourage you to write code which is more friendly to auditor or to formal verification. The second thing, which is related to the talk we have seen previously, nobody can ignore AI. And AI is doing a lot of things in this space, and we think it even can do more. And it can increase security by preventing bugs, but also by doing many other things. And I'll show you some things, but I think there are a lot of things you can do. You can play with AI, and I really encourage. And the third thing, related, of course, to formal verification and tools, how can tools work together with AI? And there's a lot of projects going on, and I'm going to talk to you a little bit about baby steps that we have been doing in Satora, combining AI with formal verification. Recently, actually, yesterday, we published a blog about it. We are using AI and formal verification really together. If you have questions, please ask me. Otherwise, yes, there's a question, please go with the mic. Go with the mic.
And first you said to build the code in advance before bringing it to you in a way that an auditor would be able to look at it. Will you be talking to us about what that entails, like how to build code that is audit friendly?
Yes, thank you. This is exactly coming in the next slide. I'm going to show you some examples. I'm not going to use, of course, a specific project, but it's inspired by a specific project. I'm going to show you how to write things, and it's interesting. And you should think, I think the biggest thing to think, you think about it. Usually, I remember, again, you see me, I'm probably one of the most senior guys in this case. I program in APL. How many of you have programmed in APL? I believe it's 0, right? Do you have anybody write program in APL? Did anybody listen about APL? It's a language that Did anybody know it? Amazing. You should take a look. It's a beautiful language, supported by IBM, but it's terrible. It was write-only language. The idea is you can write a program that usually takes 10,000 lines in 3 lines. But these 3 lines are not readable. So who cares? Okay? And it's a language that is very good to sharpen your mathematical skills, but we don't care. It's so this is a bad language. I hope it doesn't exist. Okay. Let's continue. Okay. So I'm going to talk first about how to make the code simpler for formal verification, and if you can take, or for auditing, and if you take it from this talk, this is the most important thing. So, wait a second. Okay. So how do you make this verification-friendly mindset? You don't need to be an expert in formal verification. You need to think about reading your code and understanding your code. It's not actually that you need to understand the technology. The technology can be very advanced, sophisticated algorithm, but you need to think about understanding your code. Okay, so these are several things. I'm sure there are more. These are several principles. They're simple, and they're based on our experience in Soroban, but there are more. There are more. There are more. And I think Soroban did a good job. Thomas is not here. But Soroban did a good job in simplifying things, but still people can get things wrong. So keep the code modular is a very important thing. Separate the core from the logic, and this is a good thing. Fewer states, we will understand. And actually use exhaustiveness. We know that Soroban things are being written in Rust, so the compiler is helping you. But you need to help the compiler to help you. And prefer simple data structure. We see people overuse complex data structure. In many cases, vector is enough. And you have to think about your logic. Okay, so I'm going to focus on the 2 things, but the rest is in the blog. So the rest is in the blog that Chandra wrote. Okay, so here is a simple code. And it's a code that we don't like, okay? It's based on a real code. Maybe I let you stare at it, because I'm also not a Rust expert. I've probably written 3 or 4 programs in Rust in my life. But what's wrong with this program? It's a perfect program. There's no bugs. But still, it's not so nice. What's not so nice about it? Okay. Sorry? The mic, please. With the mic. Help me out.
Now the stakes are high because everything's one function as opposed to in a way that you can easily test modularity.
Amazing, amazing. So each line is fine, but when you're trying to understand, it's like spaghetti. Okay, spaghetti is good for food, but for us it's very hard. Okay, so you end up. So basically, what you do. So you see, it's monolithic. The logic is one function. It's difficult to audit, to test, to verify. Of course, you can analyze it. So what we do, and this is what we do, we separate it. We use modularity. So you see now we have this handle, which is the handle of the deposit, handle of the withdrawal. We separate the logic. This code is much more understandable, and it's also easy for us to formally verify. Okay? So it's also easy to audit and to test and things like that. So that's one example. Why is it not? Okay, so another example, and I'm sure there are more. So what's wrong with this code? So here, you can see that a lot of things are going on in this code. Okay? So you see that we are loading the state, we are computing the amount, we are doing the error handling, and we are doing more and more things together. This makes this code very, very hard to understand. And it's also, of course, to formally verify. So what we do, so it's mixing all of these together. So a better design is separation. Again, you separate it. You have this compute borrow, and compute borrow, it actually captures the whole logic, and the main function, it is calling compute borrow. So it's all sort of, now you see that it's compartmentalized. There is a separate module, there is a separate function that handles the logic. This is the function. We need to, of course, make sure you put this, and we put it into a way that we can test it and formally verify it on itself. For example, using our tool. And then we have the core part, and we, of course, have to handle the corner cases and make sure that all works together. So this is the idea, and there are other things that you can do to make formal verification better. Please write it in the model. So now I have an interesting question to you, and actually, this is an interesting question. How do you go from bad code into good code? And that's actually a question that if you asked me a year ago, I wouldn't know the answer. How do you go from this bad code to the new code? If you give me a program with a bad code, how do I go to a new code? It's related to the talk you've seen earlier. What do you do? What? You said it.
Using AI.
Exactly right. So this is the second part of the talk. In fact, you can be lazy. You take the bad code, you ask the AI actually knows all the things that I told you. It knows how to do this. It knows. You tell him not to make it spaghetti, it will make it not spaghetti. It's interesting. So that's the second part of the talk. Okay. So the role of the Soroban, we want to develop a verification mindset. This took 3 parts, so now I'm going to show you how AI can help us. And AI can help us in many ways. Some of them we understand, and some of them we are trying to understand. And we in Satora and many teams, we see that they can do many things with AI, and I'm going to show you some. Okay, so let's see. We want to make this better practice for AI. And we want to, one thing that AI can be useful is refactoring. Refactor a code which was insecure or not good for formal to make it good for formal. You can use the AI. So you see, this is the case here. You see, here is the prompt. Chandra wrote the prompt. Hopefully I can read to you, but you see the prompt is pretty, can you read it from the last line? So basically you see, it's actually telling you the exact thing to the refactor. And then you see that in fact the AI taking the borrower and actually replacing it with the other part of the borrower. So in fact the AI can do this thing that I told you. Of course we prefer that you start on the right hand side. But if you go on the left hand side, the AI can go and help you. So the AI can make your code modular, and I haven't demonstrated in the second example, but in fact Chandra tried it and it's working. We couldn't fit the slide. So AI can help us there. Okay. So AI can actually help you to rewrite the code to make it more understandable and more formal verification friendly. That's great. So it's basically, and the question that you ask, how does the AI know that it's semantically equivalent? This will, so how do you know that the code generated by the AI is actually equivalent to the, how do you know that the code on the left and the right are equivalent? That's a question for you. How do you know? No, not Nathaniel, it's not fair. So somebody not from Satora. Satora cannot answer. So how do you know? Please answer me. How do you know? It's a confusing question. How do you know that the code on the left and the right are equivalent, that they behave the same? You have somebody with a mic.
Maybe compare bytecodes, the compilation result.
Compare bytecode, interestingly, but how do you know? How do we know? How do I know? I go this thing, I go, yes, maybe somebody else, you want to answer something else? Here.
Write test first.
Okay, you write test, but it's all good, but the answer is that we really don't know. Most of the time, the AI is doing things which are great. But sometimes the AI can do, and I can show you examples that the AI will not do a good job. In most cases, we don't know. And this is actually what I'll show you in the third part of the talk. Okay, so that's the idea. So we developed this thing, and we want to make it so it's correctness preserving. So this is the third part of the talk and the last part of the talk. We think that AI and tools can work together. AI can work better together with testing, with formal verification, and they complement each other because they think in different ways. AI is very smart by thinking locally. Formal verification is very smart by thinking globally. And they actually interact in a very good way together. So that's how we do, and that's actually what we are ongoing developing in Satora. So we develop tools that actually basically work together with the AI. So the AI assists the formal assists the AI, there are other companies, I think I mentioned already Amazon, there are other teams that are thinking along the same way, thinking about equivalent, thinking about properties that you can do. Okay, so this is an example of our tool, but I'm sure you can use other tools, Fuzers or other tool. So this is our tool. I think I've shown it last year. Basically, you have the spec. In our case, we write the spec for Soroban in Rust. We have the code that's also written in Rust, and we compare that they have the same behavior. This is actually the Soroban tool that you can try. It either finds proof, but more interesting, sometimes find also bugs that can happen in a rare situation. Okay. So what can we do? We can take the spec, and we can actually take the code and check that the code which is generated by AI adheres to the spec. And in our case, we think that with specification that we have, we get a code which is much better. And actually, this has improved the code, of course. And in the future, maybe we can also generate the spec from other things, from natural language, and also compare the spec to the code. But that's the idea. So that's what we do, and we have the open source prover. You can try that. We can also check the compliance. So for example, we take the code, we take the refactored code, and we check the prover against the refactored code, and we see that they behave the same. And we are even thinking of something which is a follow-on. Basically, this is something we develop now for EVM. At the moment, it's not yet available for Soroban. But in the EVM case, we can check that two pieces of code are equivalent without specification. And this is very useful. It's already identified a live bug in the EVM compilers. So it's a technology that you can use to check the code and to check the compilers. And basically, we can use it, and we use it with the LLM. For example, we take the Soladly, which is one of the most complex libraries in the EVM ecosystem, and basically, with few iterations, the LLM was able to drastically simplify it and eliminate the assembly code, eliminate many things. So it actually makes the code easier to audit. So that's the idea. So basically, we have the human and the formal verification working together, and the AI sits to the DeFi, and they are all together. So that's sort of what we want. We want the AI and the formal to work together. So that's sort of the talk. Basically, what I want you to come up with from this talk is, first of all, make your code amenable to formal verification. Second, use AI. And third, combine the AI and the formal verification. You can use our tool, you can use other tools. So I'm happy to take questions. Thanks. Questions? Please. All of it, by the way, it's the Soroban, also equivalent checker, all is open source now. You can try, and you are welcome to try that. We use Claude, but it works well with other LLMs. You can try other LLMs. And you can use it to find vulnerabilities. You can use other things. No questions? Here, there's a question. There's a question. Please.
I was wondering, how is the advancement of computing processing power, how is it expected to change the power or what we are able to do with formal verification, since computing power is one of the constraints of formal verification?
So sorry, I didn't understand the question. How is the AI going to help with this? Is that
no, the advancement of computing and processing power. for example, quantum computing, it's not there yet, but the advancement of how fast computers can run things and do mathematical operations.
Amazing question, amazing question. So it depends on the solver. For us, our solver is based on SMT. And SMT heavily relies on complex question. And yes, quantum computing will help us a lot. Quantum computing can change things a lot in SMT problems. There are people working on it. I can refer if you want. For us in Satora, we are affected it indirectly because we call these solvers, they are basically black boxes. And the teams we are cooperating with them, for example, specifically the CVC5 team in Stanford, but we collaborate with Microsoft Research, with many teams who are building it. So basically, the answer is that this will improve formal verification a lot, the quantum computing, when it's available, because it's meant to work with problems which are NP-complete and harder. Thanks for the question. Other questions, please? Here, there's a question, please. Thanks for saving me,
yeah.
Please.
One basic one, how to get started with formal verification? What is your advice?
How do you start with formal verification? Yeah, that's a hard one. I think what you can do, for example, in our website there is tutorial. We know that the other teams, for example, Rare Skill is a team that have a tutorial. We know that Cifrin, which is I think they have tutorial. So you take a tutorial, and it depends what you are doing. If you are a developer, are you a developer? So I would start with your own code. I will start with your own code. Did you write fuzzing? Did you have? So I will start with something like fuzzing. I will start with some kind of a test. You have a unit test. You say, okay, I call this function, I expect this to do that. And you see how this is working. And basically, formal verification is somehow doing it on steroid. Now, you have to say something more general. Here is an environment which is maintained. And the beauty of formal verification is that it's interactive. And people say sometimes it takes some time. It is a learning curve, but you can do it gradually. And a lot of teams, including Satora, have a Discord, but a lot of teams are helping with formal verification.
Okay. I think we're out of time for questions.
Sorry?
We're out of time for more questions.
Okay.
I know you
Thanks
were
a
on a
lot.
roll.
Thank you for listening to me. As I said, there is a blog. There is a blog that explains everything here. So please, thanks.
Thank you.